So, hi everyone. Good afternoon. Welcome to the session on Anthias from Raspberry Pi to x86. Here we are going to talk about how we migrated the Anthias from Raspberry Pi to x86. So yeah, let's get started. So before starting, I would like to introduce our team. I am Salman Faris from Screenly Customer Success Team. I'm not an AI, I'm a real person. Okay, I'm just joining remotely. And joining along with me, our open source developer and software engineer, Nico, who is the key maintainer of the Anthias project. Okay. So what is digital signage? So that's the first question, right? So basically, digital signage is a electronic screen that display information, advertisement, and multimedia content to a target audience. Digital signages are everywhere. So if you already visited the booth, you can see like all the booth have a screen that shows like what the booth is about, right? That's also digital signage. And you might see these in the railway station to list all the train departure and arrival details, flight timings, restaurant menus, etc. So unlike traditional signboards, which is based on a paper print or static board, this one is dynamic, obviously, because it's digital, right? And you can change the content anywhere from the world. So that's basically digital signage. Signage with the power of digital. Yeah. So you might already familiar with these images a few months back, right? There's a bigger kind of trouble happened. So detailed signage is also like facing many cyber attacks and need a good maintenance. As you can see, most of the companies are not using the right tools for that. They might be using a generic operating system to run the digital signage content. As a customer, we want to run digital signage solution in a stable and just works. We just need to works and make it a stable. Yeah. So that's why we are discussing about Anthias today. So Anthias can turn any Raspberry Pi into a powerful digital signage system that show your content in minutes. Previously, it was only limited to Raspberry Pi, but recently we ported the Raspberry Pi software into the x86. So today we are going to share that story actually. What are the challenges we face and how we did that eventually. Yeah. So before get started, I would like to give introduction about Anthias. So this is the Anthias actually. Anthias have a mainly two part. And one is the dashboard. You can see this is a web page, right? In the dashboard, we can actually add assets. Assets means the contents. We can add like images, videos, web page, etc. And we can also schedule the task. Like in the data science space, we might need to show image in a particular date and particular time. So we can schedule the content from here, etc. Now, another part is like we have the Raspberry Pi or the x86 device that actually connected to your monitor or your TV, which that will be stream the content to the TV. Depends on what schedule actually you added on the dashboard. So that's basically two part. Okay. And yeah, as I mentioned, you can use images, videos, and web assets actually to stream to show the contents. Yeah. And why Anthias? Because Anthias is the most popular digital signage product on GitHub with over like 2.5K stars. And you can see like it's runs on Raspberry Pi 2, 3, and 4. Right now, we also tested on x86. So that's also almost completed and it's running actually. And now you got an idea about what is digital signage and what is Anthias. And this is fully open source. And yeah, and I would like to also share about Anthias architecture. So basically, the Anthias have a two kind of interface. One is the dashboard, where the admin can add assets and where they can schedule and etc. And another part is actually the monitor controlling part, where the users or the customers can see the content that obviously via a monitor or a TV. Okay, I know you might interested more about the internals, right? So when you look into the internals, these are the modules inside the Anthias software. You can see we have the main part is as Anthias server, and this server is actually managing the front end and back end. And we obviously have a Nginx and this Nginx, which manage all the reverse proxy to manage the routes. And we have the Celery, and this Celery basically manage asynchronous job queue, like turn off the device, reboot the device, etc. Sometimes we need to do that, right? And we use the SQLite for as a persistent DB to store all the content and assets. And we have the Redis as a in-memory DB and state management. And we have a module called Anthias Viewer, which actually manages the display control and asset looping. So this is about the Anthias architecture. This is an overview. Anyway, we'll go into deeper look. Okay. So this is the most interesting part of this slide. Like recently, we migrated Anthias to the x86 because previously it's only supported on Raspberry Pi. And we recognize that many people have old and unused computer that can be repurposed instead of discarded. Okay. So by enabling Anthias to run on this device, we are helping users breathe a new life to their hardware. And this is the cost-effective solution while contributing to sustainability by reducing electronic waste, obviously, because you don't need to throw your computer. You can use it as a digital signage in your office, in your home, in your library, and it's fully open source and free also. So to talk about more about the migration process and the challenge we face, I invite Nico, the main developer of the Anthias project, to the stage. Welcome, Nico, and over to you.
Hi. So let's dive into details. So one of the challenges that we faced recently is most parts of the code are hard-coded to work with Raspberry Pi. So and most of them are all over the place. And yeah, here. So we have to modify like various parts of the code, like shell scripts, Ansible scripts for automating installs on Raspberry Pi devices running Raspberry Pi OS, which is basically Debian in the core. So, and we also have to modify Python files, which is what like 80% Anthias consists of. And also, the core of our digital signage solution is currently a web browser. So we need to like build precompiled binaries for Qt for x86 devices, more specifically like there are 64-bit x86 devices. And we also have a plan to ship it as Balena OS-based images, which I will be discussing later on. And with these pre-release images, we cater users who doesn't want to play around with the command line too much, so they can just download the images from our GitHub page, flash the SSD or hard drive, put it back in the x86 device, and then boot up their device. And it should be ready in a couple of minutes or so. So as I mentioned previously, we use Qt for asset display. So generally, Qt is a tool for creating user interfaces. And you write in C++. And you can also use the Python bindings for them. So in our use case, We use Qt for the web view, which is basically a browser wrapped around Chromium. So one of the big questions is why not just use Chromium? Why use Qt? So the reason behind that is that we want to have a way to like remotely control what assets are to be displayed, like from our server component, which is written in Python as well. So there's that. And then now that I mentioned, we are Qt's display is controlled from the web server. So previously we used Flask for our web server, and we recently migrated to Django. So there's a reason behind that. The first one being we want our dependency all in one place, and about the database, it's easier to not just touch the bare minimum SQL code, especially for Python developers out there beginning to learn Python. So they can just modify the class, run a command that generates the migration files, and Django will do the work for them. And so what are the challenges that we face when migrating from Flask to Django? First of all, there are multiple SQL statements scattered all over our code base. So it took a lot of work. And currently we have live fleets running in Balena Cloud, which I will be discussing later on. And it's a lot of work to migrate everything, because we don't want to risk fleet users losing all of their data. And also we have to split our migration process into multiple phases. The first one being we have to change the dependencies requirements first, migrate the views. That way we don't have to worry the data being lost. And then there's the second part, which is the database migration itself. So I mentioned that we use Balena for over-the-air updates. So Anthias can be installed in two ways. One of which is you can flash your microSD card with or install Debian or Raspberry Pi OS in your machine. And the second one is you can, as I mentioned previously, you can download our images from the releases page in our GitHub repository, and then just download which one is compatible with your device. So if you're going to run your digital signage on Raspberry Pi 4, we have our Pi 4 image for that, and so on. So let's dive deeper. So here's how we do over-the-air updates via Balena. So let's say the user has set up their digital signage solution. So if the developers or other open source contributors push their code, a continuous integration process will be triggered. And then when that happens, Docker images will be built for each of the platforms that we currently support, specifically Pi devices and x86 devices. So when the image are finished building, it will be deployed to Balena Cloud, and those updates will be pushed to the devices that are online. So yeah, and I want to dive deeper in the process of how we ship Balena images as well. So we as a maintainer, trigger a CI workflow for building images. So the code will be checked out in GitHub Actions, and then images will be generated. Then it will be configured afterwards. And then when that happens, depending on what tag or what version label we put in there, a new release will be created. So it's just one push of a button, and bam, a new release will be created. So here's the data flow version of what I've discussed previously. So currently we have releases from Pi 1 to Pi 4, and then once the releases are ready, it will be forwarded to releases. And in the future, maybe sooner, we will be supporting fleets for x86 devices. So there's that. And here's, I'd like to demo our solution. So this is what we showed previously. So here's the video for adding image assets. So you just have to click the button for adding assets. A file manager will show up. Then you can also add default assets. Currently, we have the clock app and weather app in stock. So we can use that to display weather info or time info. And lastly, you can also add videos. It can be any format supported. So it can be in MP4 in AVI. So there's that. So yeah, and we also have a roadmap that we follow. So yeah, we recently migrated to Django. So yeah, and we will be supporting x86 devices in Belen OS soon. And after that, maybe you can package Anthias as snaps. And yeah, hopefully we can also support multiple devices running not just on Debian or Raspberry Pi OS. We are also aiming to support devices running Ubuntu, for instance. And after that, we'll be adding support, WebUI support for if you want to migrate from Anthias Screenly. We will be implementing migration of assets from Anthias Screenly in a click of a button. And then we'll be doing a web interface overhaul to make it look modern. Maybe we can also do some retooling, use React, for instance. So yeah, that's it for our talk. Yeah, questions are appreciated. All right, thank you so much. Yeah, and don't forget to start us on GitHub, feel free to fork our repo. And yeah, we also have forums, a forum for Anthias, so yeah.
Yeah, so is this mic on? Yeah. I was just going to help Nico a bit with the Q&A here.
All right. Thanks, Peter.
Thank you. Really interesting, and also really interesting the way you described these choices of technology stacks that you ran into, the way, Qt and Chromium, Flask and Django. I wonder if you could say a little bit more about that, not about those particular choices, but about the fact that we always are making these choices in software projects like yours, and how much of our time is spent making those choices and then executing them and hoping that we've made the right one.
I can start with answering the design and the questioning or the analysis part of that, I guess. And for us, it was really the main reason for kind of moving more towards a standardized stack really stemmed from making it easier for new contributors to come into the project. And the less custom code we have to write, the easier it will be for new maintainers to come in and join the project. So that was kind of the thought process around standardizing tooling, particularly on the database stuff, adopting an ORM, making it easier. That was really the main objective for why we decided on moving towards the stack, right? In terms of how much it took to implement. I think that's a Nico question. You spent this year a big chunk of this year.
Like a couple of months, I guess, like making the right decisions. And since this is an open source project, we want like to reduce the barrier of entry to like developers. Yeah, because I've been pushing forward for a developer-friendly setup. So yeah.
But you spent what, 2-3 months this year?
Yeah, 2-3 months.
Throwing out like custom code and just adopting like boilerplate upstream code, really. So I think, does that answer the question, or anything?
Thank you very much.
Cheers.
Thank you.
We have another question over here.
Yes, I have one question. I was wondering if the front end and the back end, in how far they are coupled to each other. Because I can also imagine that the front end and the back end, separate from each other, could also be useful.
Let's clarify on the definition of front end and back end here, because front end can mean two things. It can either be the actual what's running on the screen or the management interface. Which part of that?
I mean the screens. So
the screens, okay.
Yeah, the front end of the management, I understand that.
Yeah, exactly. I just wanted to clarify that was the direction, yeah. They are completely detached. Do you want to speak a bit about that, Nico?
Yeah, so for the front end, which if you're referring to the display, so they're like almost completely decoupled. So we have this web server component, which is like decoupled from the service that directly controls the screen on what to display next. So if it's time like to display image A or video A, that component will just receive a signal from a web server, and then that like web view layer will like tell the display, be it TV or monitor, like, hey, display this one.
So there is a D-bus interface between the viewer and the actual server side of it that instructs what the display should show in, and they're completely with different stacks. But does that answer the question?
Yeah, very much. Yeah, thank you.
Perfect. Do we have any more questions? One more question.
So I was wondering, in the diagram you have many parts and one display screen, right? So I was wondering, is it on the roadmap an idea in the future to support having one system with multiple display screens where you can manage like what is on the screen separately, independently, without it being the same content?
So that's kind of like, that's our commercial offering, to have like central management for like a large number of screens. Having said that, we have had, there is an API for this. So we've had people in the past who have built orchestration layers on top of the API for each device to orchestrate multiple screens. So it is definitely possible. We're not stopping anyone from doing it. It's just, it's kind of goes against the directions of the company to have, just to kind of separate this a little bit, but it's definitely, technically speaking, possible.
So, yeah, but if you're referring to like using like multiple, like for example, 2 monitors for Anthias, it's a thing that we will be supporting in the future as well. Yeah. But currently, it supports only a single screen. Yeah.
Any more questions? All right.
Thank you.
Thank you, guys.
Thank you so much.